We're still here at the TM1, and we're going to go to step 3, which is load and set tool offsets. Load tool, set correct tool setting in MDI VQC cycle, and then load the cycle, run the MDI, activate MDI tool setting cycle, stay aware of any crash issues with the red feed hold button, and continue to load tools and review the tool offset page. So we used to load each tool and set them as we went, but now we preload the tools. Now in our setup sheet we have here all of our projects use a 3-inch face mill on the first tool. Tools 2 through 5 may change. So when I'm loading tools, I'll take the tools and find them, like this drill here, and I'm going to put them on the bench in the order of which way I'm going to do it. Also, this has, the tools like this could roll off the bench because they're round. So if you put the side with the notches like that and put them in order, then you don't have to worry about that. So I'll put 2, 3, 4, 5, and then load them in order. Now, how do you check tool sizes? Because a lot of these tools are in our carousel. We're just changing them. Like I have end mills here, drill. This is a tap holder. These are different end mills. That's a small end mill. Or you may have to come over here and see what we have over here. End mill, tap, roll tap, chamfer mill, drill. Alright, so if I'm measuring tools, like the first tool will be end mill, we always leave the face mill in tool 1, so that should be a given. This is our 3-flute end mill, and 3-flute tools are very hard to measure across. So if I take the tool, put it here, and you don't want to drop these tools, these copper tools will just shatter. I measure down here where the shank is. So if I take this tool and measure, I'll just put my hat back on, and I turn on my caliper, zero it out, and measure it down here at the shank. That says 373. So typically they're within 1 or 2 thousandths with the caliper. That would be a 3/8 end mill. So on this one, we are looking for a .500 end mill. But if I was lining these up, I could line this one up and then get a chamfer mill. Chamfer mill has the 90-degree point on it, and I would measure this diameter right there. So this one you can measure across the 2 flutes, because this is a end mill and it also can drill. So we use that for 2 operations. We do the chamfering, and we also use it for spot drilling. That would be like selection number 2. And then we need to find a drill, 0.228 diameter. So these are drills, and what we want to do is, if you can measure the flutes, fine, but it's really easy to check it down in the round area. And typically drills are about 2 thousandths smaller on this end than this end. So that would be the measurement for that one. That would be 2, 3, 4, and now we need to find a tap. So taps, we use a tap holder system, and these eject in and out. So these are quick disconnect taps, and this comes out by doing that, and also you push on this and this will take the tap out. So in this you want to review the data on this. So this says 10-32, so that's a number 10, 32 threads per inch. So also when you install these are driven by that square there. So they're gripped by, press on the plunger, put it in, but you have to verify that it's in the square. So if you happen to change them, and these come in different sizes, so over here we have different size of the squid. There's a real big one there, medium one, but all the same on this end. So this is going to grab this, and this has the little notches like a tool holder. It has to be in there. And if you're putting this in there without seeing, if I put it in there like that, and I can still spin it, that means it's not in the square. I have to push it in and make sure it's Like right now I can't get it in all the way, and now it drops in. Now that's in there good. So this would be our 5th tool. So we'd have face mill, already in tool 1, 2, 3, 4, 5. End mill, chamfer, drill, tap. End mill, chamfer, drill, tap. Now we just did this for demonstration purposes, so we actually have already loaded the correct tools in here. So as we're loading tools, and I'll demonstrate a tool load right now, I'm going to call up an empty tool pocket with my T6 MDI ATC method. I'll change tools. I'm going to load this tool right here. Now you don't want to grab this end. This is the sharp end. You want to hold it like this and make sure this has been cleaned off. And we have an end mill in that one, so I'm going to go to the next one. Now I can just hit ATC forward. It goes to the next tool. Alright, now to load tools, if you're in memory, the button will not work. You've got to be in one of these other modes, like handle jog or MDI. Now these notches need to go in here, and you can't, that's why I can't have chips blowing in here. This needs to be clean in here. And if you have any trouble in the beginning, if you turn these towards you, and you can see where these align right there. Now you can press and hold this, but you don't have to be fast. You can just press and hold, take your time, put it in, make sure it's lined up, and let go. And this doesn't touch, but it has to be in there. This is an incorrect load. This won't line up with the tool changer, and the orientation won't be, and this will crash, and it's not on the taper. So you need to fix it by doing that. That's a correct load. And to take them out, it's just the opposite, and we would just take them and put them in the rack. Okay, so we've already loaded the tools in, and now we're going to go set the tools up. So we're now going to go to tool settings. So it'll be MDI program. Back on this page again, we're going to go down to tool setting. Okay, pretty much we only use about 4 different settings in here. I call this small tools, big tools, and rotating tools. Okay, in our system here, this is called the OTS, the one-touch sensor, and this pad here is the trigger right here, and this is also has a battery that tucks to the probe, and this has to be parallel to this surface. When you mount these things, or if they become loose, you got to let somebody know, because it won't do this correctly, or if it's tilted at all. So this has been calibrated and parallel to the Z-axis. So what we're going to do is use the trigger probe system to touch that off. And this disc is a little bit under 1/2 inch, so we set a rule of 1/2 inch or smaller. We can use the small tool method. And if we need a bigger tool, we can use big tool or rotating tool. Now the big tool is obviously like the face mill. So first we're going to do the big tool. So if we go to big tool, it says manual length only, which means I have to manually change the tool and put it in there. So I'm going to do that right now, and that's in tool 1, ATC. Alright, changes tools. Tool 1's in the spindle, that's our 3-inch cutter. Double check that the edges still look good. Yep, all the bottom edges are the cutting edges. Alright, back to MDI program, tool setting. Manual length. Alright, manual length, hit enter, and it says right there what to do. Handle flute above OTS disc about 0.4. So you're going to see this very common. The spacing is always going to be the 0.4, 10 millimeters. Alright, I'm going to actually bring it down right now while I have the picture, and I'm going to press the X-axis. I'm going to hand draw it over there, and I'm in the large or extra large increment, which is 10 thousandths per click of the manual pulse generator. Then I'm going to bring down the Z-axis. You also have to be aware of any other issues here, like this and that. Alright, and according to this, we want to be with the cutting edge above there, cutting edge. Alright, so I'm going to move this a little bit this way, and I'll go wrong way, right way, bring it right about there, and go to the Z-axis, and now I want to change from handle to knob, and I'm going to slowly come down and just make sure I'm clear on both sides. Looks like I got to do a minor adjustment this way, and I like to just turn it so it's facing me just like the picture right there. That should be clear. I'm going to bring it down a little bit closer. And if I'm not sure about my space, I could just double check my space. That's pretty good right there. Alright, now we have to shut the doors. We got to write the program now. Only one question. What's the tool number? It's 1. Hit enter. Output to MDI. Enter. Now it's MDI cycle start. Alright, green lights come on and it touches the trigger and sets tool offset. We're setting these numbers right here. So if I had no data in here, like in order for me to make that 0, if I do 0 enter, I'm adding 0 to that. If I wanted to say 0, I'm going to 0 and I'm going to hit the force. I'm going to force it to be 0. So I'm going to 0 all these out. Now I'm not going to 0 it like I did the tool offset page because it's going to wipe out this number, and that's associated to my probe, so you don't want to lose that. So right now I have no tool offsets. I'm going to do MDI, and I still have my program here. If I hit reset, it's still there. Make that active and cycle start again. All right. So what that did is set that number.